Cool. So I'm going to try to keep within time because we're 5 minutes over already. So yeah, my talk is called Of Course That's a Thing, How CORS in the Cloud Still Kills Security. And if you've done a bunch of web development and you've dealt with CORS before, then hopefully this is very boring to you. As was mentioned, my name is Eric Lincoln. I'm a cloud security researcher, and I do applied mathematics. I also presented at DEF CON. I gave a talk on a piece of something I'm not allowed to call malware called Sassy Boy, which uses SAS applications as command and control. So evading your IDS. So have fun with that one too. Cool. So today we're going to talk a little bit about what is CORS, how does it work, where does it fit in the cloud, how does it impact my security posture, and most importantly, how can it go wrong, right? And don't worry, we're going to make this AWS relevant. I'm not just going to talk about something that none of you care about. So what is CORS, right? CORS stands for Cross-Origin Resource Sharing, and essentially it is a way that the server tells the browser that it's going to make something called a cross-origin request. And I'll explain what that is a little bit more. But it's essentially a built-in loophole to bypass the same origin policy, right? So what is the same origin policy and how does it work? And I jacked this graphic from TrustedSec because it's better than the one that I tried to make because I suck at making graphics, which you'll see later. So the same origin policy, it essentially makes it so that if you're, right, say you authenticate to your bank, and your bank uses cookies because it's, I don't know, it's 2004 and they haven't figured out how sessionized things are terrible, right? So you authenticate to your bank and then somehow you end up at a malicious website, whether it's a watering hole, right? Like an injected script on Forbes.com, which happened 2 years ago, 3 years ago, something like that. Good stuff, really. And, or you get phished or whatever, right? We all end up at malicious websites from time to time. Sometimes on purpose, usually not. So when that malicious website prompts your browser to give it the cookie and make that cross-origin request, the same origin policy makes it so that maliciouswebsite.com can't pretend to be you and log into your bank and wire all your money to some offshore account, right? So it's a security control. And CORS makes it so that you can purposefully bypass this security control. Why might you want to do that? Well, the thing is, cross-origin requests are pretty broad and pretty common, right? So if you're going from like ericgalinkin.com to test.ericgalinkin.com, that's a cross-origin request. If you're going from HTTP, just HTTP ericgalinkin.com to HTTPS ericgalinkin.com, that is a different protocol, right? It's HTTP versus HTTPS. It's over a different port, right? It's 80 to 443. All of these are cross-origin requests. And there are lots of cases where you might want to do that in totally legitimate fashions. What are some other reasons, right? Say you're using a CDN and you want to deliver dynamic content via CDN to your website. That's a cross-origin request. Web fonts, cross-origin requests. Do we all believe that cross-origin requests happen? Okay. So how does it work, right? What are the technical implementations? Well, the server talks to your browser, right? That's how web browsing works. And there are two associated HTTP headers. There are actually several, but these are the ones that the server deals with. And therefore, if you are deploying CORS, they're the ones that you have to deal with, right? The browser sends an origin, and then there's access control allow origin and access control allow credentials. Access control allow credentials is very simple. It's a Boolean field, true or false. Either you can pass credentials or you can't pass credentials. Access control allow origin is where things get complicated, and as we all know, when things get complicated, thank you for coming. As we all know, when things get complicated, things get broken. So we'll talk a little bit more about that. It accepts domains and subdomains, wildcards, and then the null keyword. We'll talk more in depth about domains, subdomains, and the null keyword. But wildcards seem promising, right? The access control allow credentials true and access control allow origin star seems terrifying. And it should be, and it kind of is, except that W3C, way back when, decided to make it so that all browsers have to basically assume that access control allow credentials is false when access control allow origin is star. So you cannot misconfigure it that way. You still shouldn't, because there are lots of things you can do without passing credentials, but it is not a valid configuration to have access control allow credentials set to true, which is at least a tiny bit of forethought on the part of W3C. The null origin is so cool. I love it so much. We're gonna dive back in later. This whole talk is just a circle, right? But essentially, the null origin is, in the spec, it's for redirects. So if you have a redirect cross-origin request, right, then it gets the null origin, and so you may want to allow those redirected cross-origin requests. Google's PDF reader is one that supports the null origin, which super cool. Unfortunately, for some applications, and this is more of a side note, the choice of the keyword null makes it so that if you just don't put anything in the whitelist, it allows null because the field is null. There's nothing, and they chose null as the keyword, and that sucks a lot because you're accidentally whitelisting an origin. Yeah. One of the other ways that it can get messed up, and one of the very, very common ways that CORS is actually implemented in real life all across the internet, is that access control allow origin headers are dynamically generated by a user-supplied origin. And hypothetically, the way that should work is you say, I am coming from ericgalinken.com, and some function, right, some Node.js function or Python or whatever says, yeah, that exists in this list, so we'll give you a header that's valid, and says access control allow origin, ericgalinken.com. I'm going to say my name like 75,000 more times, and I'm really sorry. Right? But, and here's where we're going to start getting into the security part of it, sometimes they don't check. Sometimes they just take the origin that you say should be allowed, and they say, yeah, that origin's fine. It's all good. They just reflect it back. And that's where things get not great. So we're at AWS Community Day. I don't know if any of you are here by accident, but that is where you are. So how does this affect AWS, right? And this is just an extremely short list of services that support CORS in some way, shape, or form. And like, I don't know, these are 4 pretty common services. I would say if you've used AWS for anything, you've probably used at least one of these services. If you've managed to use AWS and not use any of these, please let me know. I'm so interested in how you use AWS if you've never used S3, CloudFront, API Gateway, or Lambda. I'm very, very curious about your use case. So a little bit about CORS in S3. As you would expect, it is incredibly challenging to do right. So you can do it via console, SDK, however you want to configure it, it's available, right? Up to 100 rules are supported. And here's where that annoying complexity problem creeps in again. Each domain you want to whitelist is a separate rule, okay? Which means you have to write an entire CORS rule for every single domain, which is why people use things like Lambda as a shortcut to generate those headers on the fly. because writing and maintaining a whitelist manually sucks so much, okay? You can simplify your CORS configuration using CloudFront. It'll help make sure that like your ACLs and policies are set correctly, because between CORS, ACLs, and policies, the number of ways that you can configure and misconfigure access to your AWS bucket, either to allow too much access or to completely lock everyone out forever, is countably infinite. Right? And then in API Gateway, Lambda, usually you're going to have some combination of the two. And I group them together because API Gateway, if it's not a simple request, which if you're using CORS, it's not simple. You're not going to have a simple request. Simple requests are defined in the spec, but it is sufficiently narrow in scope that I feel comfortable saying that you're going to have to enable CORS support, which is separate than just turning on CORS in API Gateway. And for that, you need to plug in a function, a Lambda, that will give you the headers. And that's all in the AWS documentation that I linked down there. But in essence, if you're using API Gateway and CORS, you need to have a Lambda that generates these headers. And the chance of you copying and pasting something from Stack Overflow is extremely high. Right? So how does it hurt security? Well, it feels pretty obvious. You are deliberately creating a loophole in the same origin policy. Okay. And now I will say this does generally hurt security more for your users than it does for your business. But in the case of something like a cross-site scripting vulnerability, that can actually really get amplified if CORS is misconfigured, because it essentially gives an attacker complete control over your website. So how can it go wrong? These are some examples of CORS vulnerabilities with links to bug reports. If you would like to sit down, I would love to have you. With bug reports linked to them, this is how you get people in. You just embarrass them. Right, blogs and bug reports about CORS misconfigurations, but they're real examples that have, in most cases, proof of concept code attached to them if you're curious about the actual ways that it gets exploited. So one is a Department of Defense website allowed for user impersonation. You could steal user sessions and impersonate users on a US Department of Defense website. That feels pretty bad. I feel like if you're on a DoD website, you should really, really hope that the person is who they say they are. But maybe I'm overestimating the DoD. Probably not. Another one, a Bitcoin exchange, and this is one of two Bitcoin exchanges I mentioned. They're both mentioned in the same blog post. Had a vulnerability where you could, if a user visited your website after authenticating to the Bitcoin exchange ever, you could take their cookie and impersonate that user and take their private API key. Once you have their private API key, you can do all the things you could do with a private API key, like lock them out by changing their 2FA method, or steal all their Bitcoins, which, if we know anything about Bitcoin, and I don't, it's basically cash, which means that once I have stolen your Bitcoins, you will never get them back, which sucks. Yeah, that's not great. And then I want to talk again about that null origin. So the null origin, because it's associated with redirects, it's really, really easy to get a null origin, especially if you're injecting a script into a website. You can just inject a sandbox iframe, and you have the null origin. So say I find a cross-site, a stored XSS vulnerability on nytimes.com, Washington Post, who cares? Some website a bunch of people go to. And I inject my little sandboxed iframe, which is just going to be teeny tiny. It's not even going to be visible. That's just going to steal your cookies and make a request to whatever website it is, whether it's a bank or a Bitcoin exchange or whoever has managed to misconfigure CORS, and then I'm going to steal all your money. And it's great. And this also happened to a Bitcoin exchange who had CORS misconfigured, and you could impersonate the user and log in as that user with the cookie and steal all their Bitcoin. Again, really trivial misconfiguration, seemingly trivial misconfiguration, but you pair it with something like a cross-site scripting vulnerability, and all of a sudden, you have a very, very serious security loophole, right? But again, we're at AWS Community Day, so I'm going to tie this back in. How does it go wrong at AWS? I'm missing some things here because I wanted to have a pre-recorded demo and that didn't work out for reasons. So if you take pictures of this, it's going to completely change on the next slide. I mean, you can take all the pictures you want. Feel free. I'm just letting you know that this is not the actual architecture that was set up. Right? So if you host any sessionized app where a user logs in, a CORS misconfiguration can allow for session hijacking. We've kind of covered that a little bit. This is the right slide. And we're going to go through the whole attacker use case. But so essentially, user logs into mywebsite.com, which has an API gateway that passes a request to a Lambda, and that Lambda fetches data from a DynamoDB. I don't care what data it is, personally, but imagine, if you will, sensitive user information stored in a DynamoDB, financial records, PII, whatever you could store in a DynamoDB. I've seen horrific things stored in DynamoDBs. But whatever you happen to store in your personal DynamoDB, right, gets handed to it. And the user authenticates, goes to the API gateway. API gateway says, hey, yeah, this is cool, right? Because cross-domain, it's going from mywebsite.com to AWS, right? Cross-domain. The Lambda that checks the CORS and generates the headers says, yeah, that's authorized, absolutely. My website, anything mywebsite.com is allowed, right? That's all that Lambda does. It says, is mywebsite.com in the origin? Good, you're good to go. Lambda parses query, sends it to DynamoDB, and you get your records back, right? Your medical records, your financial records, who cares? Well, maybe the user ends up at badwebpage.evil. Whether it's a fish or a watering hole attack, it doesn't matter. There are all kinds of ways to get people to visit a malicious website, even inadvertently, especially, right, via sandboxed iframes or what have you. And so it's mywebsite.com.badwebpage.evil. And the Lambda sees mywebsite.com and goes, yeah, you're good. Cross-origin, allow, right? And then it gets valid credentials from the compromised user because they're stored in the browser. So that Lambda says, yeah, no problem. Here's the data you requested from the DynamoDB. And that can be API keys, right? All you need is an API key or some other credential that will get you further access. It may not actually be super sensitive information, but I've used DynamoDB to store credentials. Super common use case. And so, to kind of wrap it all up, just on time, you're welcome. CORS can be a real pain to configure correctly. You can be required to manage a 100 website long whitelist by hand, or you can have to write a really obnoxious Node.js script that parses HTTP headers and generates HTTP headers. But it's critical to protecting your users. If you're using CORS, you need to make sure it's configured correctly because it is seemingly benign to misconfigure. I mean, who cares, right? I'm the only one making this request. But you might not be, right? And it amplifies the severity of every bug. Every cross-site scripting is worse when CORS is misconfigured. Every SQL injection is worse when CORS is misconfigured. CORS misconfiguration itself maybe not be so bad if all you're hosting is just like Eric's blog, but it can be horrific if you are storing any kind of sensitive information. And that's all I've got. So does anybody have any questions?